My name is Brett Becker. My pronouns are he, him, and I'm from University College Dublin, as you now know, in Ireland. I'm really excited to be the SIGC Board Vice Chair because I get to present these awards each year. This is my first year. And this is super cool and fulfilling, and it means a lot to me, and I can only imagine what it means to the award winners. I am delighted to be here today to present the SIGC 2023 Award for Outstanding Contribution to Computer Science Education to Susan Rodger on behalf of the SIGC community. Nominees for these awards are nominated directly by SIGC members and require not just a nomination, but several letters of support from more community members. Susan needs little introduction in this room, I believe. She's been researching computing education and contributing to the computing education community for decades. Susan's work spans K-12 to university level, and only a few of her notable contributions include her significant work, on projects like JFLAP, which is used in over 150 countries by thousands of students, and her work and contributions to the ALICE project. She's run hundreds of K-12 teacher professional development workshops, offering professional development to more than 1,000 K-12 teachers. That is way better, isn't it? I was wondering what I was competing against. There was something. Okay, wow, this is good now, all right. So, like I was saying, Susan has run hundreds of teacher workshops at the K-12 level, offering professional development to more than 1,000 K-12 teachers. And although that's probably a career statistic, I have a feeling that was during a shorter, intense period of work. She and her collaborators have raised several $1 million in NSF funding over the course of a decade to support their work with growing the K-12 education teaching community in the U.S. Susan's total research funding well exceeds $10 million, and it's notable that much of this work that I'm talking about, especially the K-12 work, predates things like Code.org and the CSTA. So Susan has been on the leading edge of many computing education efforts isn't the right word, I mean movements. Susan has inspired many teachers and students to pursue careers in computing education and computing education research, and much of her work has been dedicated to broadening participation in computing. Now, this is a little before some of my professional time, but I believe a lot of that work was before terms like BPC were either used or at least commonly used. So again, Susan was reading the road ahead quite well. Many of you probably own decks of Susan's notable Women in Computing cards, all of which have a corresponding entry. Before I met Susan in person for the first time, I knew her not only for her webpage, which chronicles the history of the SIGC conferences, which is just one example of a small, albeit, but really, really valuable resource. Susan said, this is missing, we need this, and did it. And it's something that I refer to fairly often, largely because I have a really poor memory. Susan is also no stranger to service. She's chaired this conference that we're at right now twice. She's chaired the SIGC board and served on the board for many years. And it would be remiss of me to not mention that she has been the recipient of several other distinguished awards, including the ACM Distinguished Educator Award and the ACM Carl Karlstrom Outstanding Educator Award, the IEEE Computer Society Taylor Booth Education Award, amongst others. I would like to read a few lines from Susan's nomination and support letters to give you an insight into her outstanding contributions to computing education in the words of other community members. Susan has a nearly infinite amount of energy. Whenever a teacher would contact Susan about a problem, Susan would help the teacher solve that problem. Then she and her undergraduate student researchers would develop a lesson about the problem the teacher was facing and make that lesson available for other teachers to use. Susan is a rock star in the CS automata theory education community. When I think of, that's not me, that's a supporting letter. When I think of top computer science education researchers, I think of 3 people, and Susan is one of them. In a nutshell, Susan is an energetic, creative, and thoughtful computer science educator who has made many significant and lasting contributions to computer science education. And I, that's me, think it's fitting to end with this quote, which is not mine. Susan is unquestionably one of the stars in the computer science education community. With that, I'm delighted to present the 2023 SIGC Award for Outstanding Contribution to Computer Science Education to Susan Rodger on behalf of the SIGC community. Congratulations, Susan.
All right, thank you.
I didn't want to stop it. I'm just going to read the plaque, which you can read as well. The SIGC 2023 Award for Outstanding Contribution to Computer Science Education presented to Susan Rodger for creating JFLAP, changing how the automata course is taught, and for helping to bring computing to primary and secondary schools through her work with the ALICE environment.
Okay.
Congratulations.
Thank you. Thank you. You hold that. All right, thank you very much. It's actually not been hundreds of workshops, not quite that many. And I've only run this conference once, but thank you. Once was enough. Anyway, I do want to thank a lot of people. This SIGC is my community. I've been coming to SIGC. I came in 1993, and I've been every year since. I just don't want to miss it. But I do want to thank my husband. I forgot my belt, and he let me borrow his belt today, and my family. I've had so many mentors that have helped me get to where I am, so many colleagues, and these are some of the groups. And I've worked with so many students who've been such a joy to work with. I could have a whole talk on everybody, but I'm not going to do that. All right, so let me get started. Oh, I also want to thank Steve Wolfman and Gary Landowski. Instead of giving a conference bag, they gave a scarf, and I've been wearing it every day. So thank you for that scarf in SIGC 2010. All right, so I'm going to talk a little bit about my journey to get where I was, and then I'm going to talk a little bit about teaching. So I've always been very, very shy, especially when I was little. This is a picture of me and my sisters. My sister Sandra is here. She's the photographer. She's the little sister. And my older sister Sarah was supposed to be here, but her flight left Raleigh and then turned around and went back to Raleigh because they had mechanical failure. And then they started again and got a little bit further and then turned around and went back to Raleigh again last night. But she's online because the conference is hybrid, so she's watching online. So thank you, Kristen and others. So a shout out to her. And this picture was taken, it says May 1970, but back then, that's just when you developed the picture. So I don't know exactly when it was developed. But again, as I said, I was very, very shy as a kid. I was a very quiet kid. My mom thought I was great because I could go work on anything and get engrossed in it, and she didn't have to worry about me. But then she would worry a little bit about me because when I was too quiet. So one time I went to my aunt's house and she'd just gotten a new white rug, and I took crayons and I drew this big house with lots of black smoke, and my aunt and uncle weren't too happy with me. All right. Also, as a kid, I solved a lot of puzzles, and let's see. And like Robert Thirsk, who gave our great, nice keynote yesterday, I watched Star Trek, but I didn't want to be an astronaut. I was interested in teaching. I loved math, and I was interested in teaching. I tried to teach my little sister math a lot. She didn't really want to do it. She was more creative and wanted to be a photographer. All right. So I also, when I was a kid, I just loved the World Wide Web. I just loved it, and we didn't really have an internet yet, but this was my World Wide Web, the World Book Encyclopedia. And I could pick up a volume, and I could find exotic places, and I just read it all the time. It was so exciting to surf the World Book. And it came with this device and paper quizzes, and you would put your paper, this big sheet of paper, in this device and close it, and then you could see the questions, but you couldn't see the answers until you slid over the thing, and then you could see the answers. And that was my interactive quizzes I was doing. So I loved doing interactive quizzes before computers. And again, we didn't really have computers around, but my dad, well, they were starting to come, and my dad was fascinated with computers, and he started a startup company called American Data Processing, and this is 1964. And he didn't have much money, so he was borrowing computer time from other people, and he would have to run like accounting programs in the middle of the night when he could rent time to run the programs. But I was fascinated because I'd go to his office and see these large disk drives and these large magtape drives, and I thought that was pretty exciting. Again, we had no computers in my high school, no computers in my house. So I went to college. There we go. Went to college at NC State. It was a local university. I liked math a lot. I was going to major in math. I took a programming course my first semester, PL1. There's Hello World. It was very exciting, even though it was on punch cards. You had to take, it was a lot of work just to type one line. That's an assignment statement. Here's the first book. I still have it, my PL1 structured programming book. And you can see the types of things we talked about. We did logical testing, data types, file processing, and subroutines and functions were chapter 9. Even in the back of the book, it had these tables. Like, this is a powers of 2 table, so I could look up my powers of 2, and I could do them in binary, or decimal, or hexadecimal, or even negative binary. I don't think they put those in books anymore. So at NC State, I had some jobs. This was at the local NC State Computing Center, and my job was to pull data off of magtapes for researchers. I was writing programs for that when I was a student. And then I did some undergraduate research with Professor David McAllister. Somebody had buoys in the ocean, and they were collecting data on wave motions, and the data was kind of corrupted, so my job was to try and clean that data, and then we did computations on it. And then I was a senior, and I decided to double major in math and computer science because I liked computer science also. And I had a math advisor, but I'd never even met her because that was my second major. So at the start of the senior year, I had a question for my math advisor, so I thought I'd go meet her. And that was Professor Dana Latch. And she looked at my record and she said, "You are going to grad school, aren't you?" And I had never thought about that. My mom never finished college. My dad had a college degree, but had not gone on. No one in my family had gone on to get a graduate degree. It wasn't even on my radar. So I went back to David McAllister, who had not mentioned it either. And then he said, "Oh yeah, you should apply grad school." And he talked to me about grad school. So I started thinking about going to grad school. And I was still nervous about whether they would accept me or not. So I also applied to a job at IBM. Again, there weren't many computer companies back then, but IBM was one of the big companies. And it was also in Raleigh, where I was living. So I applied to IBM and applied to PhD programs, but IBM offered me a job and gave me 2 weeks to decide. So I was nervous, so I just accepted the job. And it takes a long time to hear from PhD programs, so I was still waiting on that. But there was a problem with my GRE scores. So I had a really high quantitative score. It was in the 90 percentile. And I had a high GPA at NC State, but I had a really low verbal score, like tremendously low, 28 percentile, which is really low. So I talked to my advisor, Professor Latch, and she said, "Well, you should get a psychologist, go to a psychologist and get an evaluation, because this just doesn't seem right. So I went and I got an evaluation, and they said that I had a learning disability. So that was a surprise. It said the disability is a subtle one, it's discrete, but it affects my ability to retain small bits of verbal information. Now remember, I was a voracious reader. I read everything. I loved reading the encyclopedia, but then I just couldn't remember that information. And it said that it believed that that was responsible for my low GRE score, and they thought that was no reason that I couldn't go on and do graduate work in the area I wanted to go on. So I sent that letter to graduate schools. I applied to maybe 5 or 6 graduate schools, and this was in February. So then in March, I got this letter back from Purdue, and they had accepted me, so I was thrilled. But they said, in addition to sending in my undergraduate final transcript, I needed to demonstrate proficiency in English composition. So that was something I had to do my first semester. But I was very thrilled I got in. Now remember, I'd already accepted a job at IBM. So you're not supposed to do this, but I called them up and said, "Hey, I really want to go to grad school." They let me in. So I don't want this job anymore. But they were very nice. I turned down the job, and they said, "Would you like a summer job?" So I was like, "Oh, okay, that wasn't so bad." So they gave me a summer job, and I went there. And then in September, I went to Purdue, and right away I nailed that proficiency in English composition. So awesome. All right, no problem. So I went to graduate school at Purdue, and I was a teaching assistant for the intro programming course, which was in Fortran. And I taught several discussion sections as a TA. And they were still using punch cards when I first got there, and eventually they quit doing that. And then I was also trying to decide what was I going to do. I like theory, math. So I was trying to decide between numerical analysis and algorithms. And I was taking a class in both of those at the same time, my first semester. And the person who taught numerical analysis was so boring. He would stand in front of the board and not even look at us and just fill a whole board with math. And then he would go to the next board and just fill the whole board with math. And then the person that taught algorithms was making it so exciting. This was Professor Greg Fredrickson, and I think also it was very visual, the way he presented it, and I could just see the data structures, and I just fell in love with algorithms. And he actually ended up becoming my advisor, and I did algorithms, not numerical analysis. And then I became a TA for several other courses while I was a grad student, and I really, really like teaching, and especially helping students. So that was what I really liked. So I did finish my PhD. It took me 6 years, but I got it. In computational geometry, a little bit of that, but mostly parallel scheduling algorithms. And we did a job search. My husband and I, he was also getting his PhD. I met him at Purdue. We had a two-body problem, but we managed to get jobs. I got a job at Rensselaer Polytech Institute in Troy, New York, and I was continuing doing research in algorithms, but also they hired 2 women at the same time, and they had not had any women faculty in their department, so that was actually great. They hired Ellen Walker and me, and it was great to have another woman faculty member there. And I really liked the teaching, though. It was, I was applying for grants and research. I wasn't getting any of those grants. But I really liked the teaching and helping students there. So I started actually developing tools to help people learn computer science at that time. And I was going to SIGSI. I started again going in '93. So this was my second year at SIGSI. And I was presenting a paper, and Rocky Ross was there. He was doing algorithm visualization. And he invited me to lunch one day. And he also invited Alan Bierman to lunch. I didn't know Alan Bierman. Alan Bierman was from Duke, and Alan was talking about this new position called this teaching track position, because they didn't really have very many of these back then. And they were creating this new professor of the practice position. They just created it. And he didn't even know I was listening. He was just telling everybody at the table. And I was thinking like, oh, well, Duke will never hire me. I had very low self-esteem. So I was listening, but I wasn't really paying attention, but kind of like, oh, that's kind of interesting. And this was in March. And then 1 month later, I finally got some NSF grants. I've been applying for 5 years, and they were in education. I got one for working on JFlap, and also one on broadening participation with Ellen Walker. We were going to do a program called PipeLink. So that was very exciting, but also I like, oh, well, maybe I could apply for that job now. So this is again like 1 month later, and I email him to inquire, like, is that position still available? And his response was, oh, we're having 3 candidates interview next week. We're going to probably have an offer. It's probably too late to apply unless our search is unsuccessful. Well, I wasn't going to give up. So I emailed him back and mentioned, oh, I just got 2 NSF grants. But he applies and says, well, congratulations on your grant success. Yes, you should send in your application, but don't put a huge effort into it, because unless you find out we've already opened our search. So I was like, okay, well, I'm going to do it anyway. So on Monday, I FedExed my paper application, because that's what you did back then. And so it landed on their desk on Tuesday morning. And on Tuesday, I got a call from this guy called Owen Astrachan, who I'd never heard of before. And he calls me up and says, can you come interview this week? But he says, I need your reference letters first, and then I can invite you for an interview. I said, okay, great. So I want to thank these people, because I asked them for a letter and I needed it like today. And I wasn't even interviewing for anywhere, so like they were surprised. So I had to go explain I'm looking for this job. So anyway, thank you very much to Mukai and Eric and Bob. And they did send in a letter, because on Wednesday I got an email from Owen that said, I'd like to extend an invitation to come this week. Can you come tomorrow evening? Now remember, I wasn't even looking for a job. I had no talk ready to go. So I had interviewed 5 years before, and I'm digging through finding, like, where's my interview talk from 5 years ago? Okay. And so I emailed him back, and I told him, I picked up my tickets this morning. So you can find me. I'll be wearing white jeans and white sneakers. I have long brown hair and wear glasses. Nobody had web pages back then. And so he emails back, I got your abstract and your self-description. I'm kind of skinny, wear glasses, and be looking like I'm looking for someone. No cell phones either. No cell phones either, okay? This is what you had to do back then. So anyway, it worked out because they hired me. And I've been there since 1994 as an assistant associate and professor of the practice. And I've been involved in SIGSI. Thank you. I've been involved in SIGSI many ways, lots of communities. I'm just going to talk about a few communities I've been to, and then I will get to some teaching stuff. I could talk all day about SIGSI, but I'll just talk about a few things I was involved with. So I was involved with the AP Computer Science program early on. This is the test development committee that writes the AP exams, and this was 95 to 2001. So what does that mean? It means there were 2 exams back then, the A, and I think it was actually called the AB exam. There was Pascal up to 98, and then they decided to change it to C++ for 5 years, and then Java in 2004. So I was on, and you write an exam 3 years before it actually goes out. So I was involved with writing Pascal exams, C++ exams, and Java exams. So, and they've stayed in Java ever since, although maybe that's going to change, who knows. And this was also a time, so you can see there's a lot of change going on in the AP program. And there were a lot of panels at SIGSI, and some of them were very heated because many people were quite against changing to C++. So there was a lot of heated panels at SIGSI, very interesting time. And then they decided to switch to Java, and those panels quieted down after that. So anyway, so that was a big part of my life when I first started, was being involved with the AP Computer Science program. A lot of great people were in there. Another community was algorithm visualization. So in 1992, and I want to thank my mentors at RPI because they saw I was doing CS education stuff, and they kind of encouraged me to look for venues to go present at those education places. So SIGSI was one of those. But there was this workshop in 1992 in Nova Scotia, and I went there and met John Stasko. He also had gotten his PhD the same time I had in 1989. And he was also doing algorithm visualization, and I was fascinated because he got his PhD by creating a tool for algorithm animation. Like, I didn't know you could do that. That was exciting, because I wrote my PhD on very theoretical stuff I've never touched since then. But that was very exciting to me, that you could do that. And then I got an NSF grant with my JFlab, and I decided to throw in a workshop. You know, I'll throw in a workshop. That'd be kind of cool to get people together, because I'd been coming to SIGSI. There was lots of people that were just starting to do algorithm visualization. I was meeting them at SIGSI. And so I had this workshop at Duke in 1996 on interactive and visual tools, and got a lot of people to come give talks. Stasko, Poplawski, Erickson, Guzdow. I saw you guys gave talks there. I was looking back at that. So that was kind of cool, just bringing together people in algorithm visualization. And then Cliff Schaefer at Virginia Tech was big on creating this AlgoViz community, algorithm visualization community, online community there. And then I attended lots of IDISI working groups. I had a lot of those on algorithm visualization. Great to think about going to an IDISI and attending or participating in a working group. It's a great way to meet other people in an area that you like. And that was Tom Knaps, was a co-leader on a lot of these working groups in algorithm visualization. And then there's been many things that have come out of that, such as online textbooks. OpenDSA is one of those. Runestone Academy is one of those. Those are all online textbooks that are just very awesome to work with. So that was a whole community of algorithm visualization. And then there's another community, which is getting CS into K-12. I gave a talk at SIGSI in 2002, and I was doing lots of different tools, and one of them was Alice. And Wanda Dan and Steve Cooper came to where I gave a talk and wanted to meet me, and that evolved into a collaboration for many years. They were also interested in integrating Alice programming into CS0. And so we had a workshop at Duke in 2005 to teach people Alice. And again, this is before like code.org, I think didn't even start until 2013. And Scratch was starting a little bit after this, but they didn't have their online version also until 2013. So this was pretty exciting to get people excited about computer science, especially high school and middle school teachers. So we ran our first Alice Symposium in 2006, a year later. These are some pictures from that. And then we've ran several of those since then. And then that eventually evolved into this program to teach middle school and high school teachers how to program called the Adventures in Alice Programming Project that we've run for many, many years in many states in the US. Okay, so I could talk more about 60 communities, but I'm going to go on. I want to go back to my disability because I was diagnosed with a disability as I was heading into graduate school, and then I didn't really think much about that after that. Like, I got this letter, it got me into grad school. Like, I never asked for any accommodations in grad school. I never even knew I could do that. I think things have changed maybe since then, or at least hopefully have changed. I've never asked for any accommodations as a professor, but it's been hard sometimes. And it takes me longer to do things. It takes me longer to write. I can do it, it just takes me longer. It takes me longer to organize my thoughts sometimes. But it's been really easier to talk about because of all these great organizations we have, such as Access Computing. Richard Ladner is a big part of that. CREWP, they're widening participation. And CWIT.org, they've had a lot of these groups have had conversations about disabilities and what you can do. So finally, I decided a year ago that I would go get another psych evaluation. And I did, and again, they said, you know, these scores reveal a large and unusual discrepancy between my verbal reasoning and my nonverbal reasoning, and that indicates I do have a verbal-based learning disability, and it actually has a name to it. It's mild high-functioning autism spectrum. So that was, and I also have camouflaging behaviors, which means I mask or try to hide my autism. So anyway, I'm autistic, and it's nice to have a name for what I have. So, and so how do I compensate for things? So I have to start things really early, or else I'm in trouble. I write down notes a lot, everywhere. So here's some of the notes I wrote down here. Yesenia, I've got some things for you. In meetings, I found that I can write down notes before I speak, and that helps me when I go to organize and I talk. I can see the words. That kind of helps you have to see the words. But it works. On my computer, I have this little sticky note that reminds me to smile because I always forget. And also to slow down, because when I teach, I tend to start talking too fast. So that I have to remember to look at the note, but I forget that sometimes. And then when I haven't taught like all summer, and now I have to go talk, I have a little anxiety before I'm going to teach again because I haven't taught all summer. I like to say tongue twisters. And those are just good for articulation for anybody. Just go say a bunch of tongue twisters before you go teach if you haven't done it in a while. And that's actually helps. So that's my journey, and now I do want to talk a little bit about teaching. So learning how to teach computer science. So I think it's fascinating that you get a PhD, that means you can teach. Really? So really had no training in teaching other than being a TA. Again, I think it's a little bit different now. People are trying to have more training with their TAs, but we had no training as a TA. It was just here, go teach this recitation. Also my first semester at Rensselaer, I was very excited because I'd always wanted to teach. And the department there had made a decision before I got there. They had decided that they wanted to combine CS1 and CS2 with automata theory. And then they said, oh, let's give it to the new faculty who just got here. So Ellen and we were like, sure, that sounds interesting. Sure, we'll do that. I don't recommend doing this to your new faculty. But we were excited. We were very energetic. And I loved automata theory. I loved teaching CS1, or at least loved CS1. So we were basically trying to stay one step ahead of our students. And this is also where I was like, oh, wow, we really need a tool for this. And that's how I sort of thought, oh, well, I should develop a tool for this. So actually, it was a good thing for me. So anyway, that's how I started teaching. So I'm going to give like a little bit of advice from my many years of teaching. I have 7 tips that I'll talk about. And by the way, I'm still learning. I don't feel like I'm the best teacher. So my first tip is just borrow, okay? Don't try to do everything yourself. Borrow lecture notes and then slowly make them your own. I mean, I borrowed so many things from my lecture notes from other people. Borrow assignments and slowly make them your own. Tweak them and slowly turn them into what you want them to be. But it's much easier to start with somebody else's and then slowly turn them. Borrow ideas. I mean, you're here at SIGC. This is a great place to borrow. Every time I come here, I always go back with so many ideas I want to implement when I go back. And here's an example from Steve Wolfman in SIGC 2002. I went to his talk where he was talking about making lemonade, exploring the bright side of large lecture courses. So at that time, classes were starting to get big. And he talked about where you could make a binary tree with your class. Like you pick one student to be the root, and they stand up. And then they pick 2 people to be the left and right child, and they stand up. And each of them pick 2, and so on. And then you could see, once everybody had been picked, you could see what the depth of the tree was. And actually, that's not in his paper, because I looked back at his paper. So it was something people sometimes give ideas that in their talk that are not in their paper. So you got to go to the paper talks, too. All right. So I borrowed that. I've used that before in my class. Nifty Assignments is another place. There's lots of cool assignments there you can borrow, but also just any of the paper talks. There's so many ideas here that you can borrow. So borrow things and then slowly make them your own. Okay, so tip 2 is make your concepts visual. So this is me as an assistant professor, no gray hair. And I was teaching on Halloween, and so I figured I'll dress up as a data structure and see if they can guess what I am. And this is the algorithms class. All right, so I'm going to help you with this one a little bit. So I'll blow it up for you. And I have this pink yarn that's in the shape of a binary tree, okay? And then I got this chemistry molecule kit, not quite this one, but similar. And for each node in this tree, I built a subtree of the same size hanging off of that node. And you can see those hanging off of the little pink nodes there. So there's one subtree, and there's another one. I'm not showing them all. Okay, so does that help? What is it? Okay, so I'll give you a hint. It's a 2D range tree. If you ever heard of that, you may not have heard of that. So here's the problem. There's points in the plane, and you want to take a square and put it down and figure out what are all the points in that square. Okay, so you have to search in the XY plane. You have to search in the X range, and you also have to search in the Y range. And then you know which points are in that plane. And so this tree, here's the main tree, which is the yarn that was on me, is sorted by X values. So you can go and search for the 2 endpoints of the X values. And then you have all of these are in the X range that you want. And you can look at those subtrees. So there's one subtree. There's another subtree. I'm just pulling them out. The subtrees are sorted by Y values. So once you identify the subtrees, then you go look through the subtrees for the Y values, and then you have all the points. Okay, did anybody follow that? Okay, so I don't know if you followed that or not, but I want to talk about engagement taxonomy. That is something we did in a working group in 2002. We talked about the different levels of engagement. And what I just showed you was an example that you're just viewing, right? You just watched something, right? Okay. So there's 6 levels of engagement that we came up with visualization technology. The first one is no viewing, okay. The second one is viewing, that's what you just did. If you want more engagement, then what you have to do is responding. So you have to show a visualization and pause it and ask questions and see, like, did you really follow what was going on, right? So that's a higher level of engagement. The next higher level is changing it. Like, can you change an animation? Do you understand enough? You have to understand enough to do that. The next level of engagement is constructing it from scratch. If you can do that, you really understand it, right? But there's a higher level of engagement, and that is presenting. If you can present it, you really understand it. I mean, that's what we do as teachers, right? In order to teach, we have to really understand it in order to teach. But the students, too. And it'd be great if all our students could just present things all the time, but we just have too many students, it's not going to work. All right. So another tip is try to make your lecture interactive as possible. So one thing I do, just very simple, is I never have all the answers on my lecture slides. So here's just a copy of my lecture slides, which I borrowed from someone. I don't know where I got this idea for this, names, types, and values. And then I would click through and go through, here's the full slide, but we'd go through and ask them, well, what is the name, what's the type, what's the value? You get the idea? Other ways to make lecture interactive are you can use clickers, Google Forms, and get collective responses. So here's a question on whether variable names of argument parameters, do they need to match? And then you can see in my class they didn't agree on that, so that's something to talk about. You can use lots of techniques for problem solving. So one of the techniques that I use is called the 7 steps. This is where you take a problem and then you want to go all the way to getting running code. And the first 4 steps are just focused on getting an algorithm. So you're not even touching your computer. You're working on getting an algorithm. You try an example by hand, just do it pencil and paper, and then think about what did you just do. You eventually get to writing it up as an algorithm, and then you go back and test it again on a new example. So that's the first 4 steps. And then step 5 is translating it to code. So it takes a while before you even get to there. You have to debug it, test it and debug it, and so on. And some of those, like, it's not going to work and you have to go back to a previous step. So we talk about this method and we use this in our CS1 class. And are they going to use it? Well, they're not going to use it unless they see you using it. So that's why I use it in class a lot. I'm constantly going back and using the 7 steps, and we solve problems in class with it. And maybe I just do the first 4 steps sometimes for one problem, or sometimes I try to go all the way through. So we use it a lot in lecture. And students do use it if they see you using it. So whatever you're using, you have to do it in class, and they'll see it. And so here's a quote from a CS1 student. I just want to tell you, I tried the 7-step method, and I worked on all of my code for 1 or 2 hours before I even looked at a computer. And then it ran on the first time. Because we talk about, like, the more you put into the algorithm and work on it before you go over here and type the code, that you'll have less time on debugging it. And so one student gave me that. All right, so here's another thing about interactive techniques. I don't know if you know about Bob Moses, but he is incredible. He wrote this book, Radical Equations. So he was a civil rights activist in the 1960s, where there was oppression with the black vote, and so he was one of many people who were organizing black voter drives to get them voted to vote in Mississippi, to be registered to vote. And they were fighting laws that were oppressing black voters. And he did a lot of this work in the 60s, and then later, in 1982, he got a MacArthur Genius Award for this work. And he thought, what am I going to do now? Well, his daughter at that time was entering 8th grade, and they didn't have algebra in their school. And so he decided to use this money to basically go to the school and say, hey, I'll teach algebra to my daughter and anybody else who wants to learn. So it was about trying to get his kid to learn algebra, but also realizing that, he saw this as like, this is oppression again, because these kids don't have the opportunity to take algebra, which means they're going to get behind, because that is the gateway to be taking higher level math. And so this started a whole new movement, which was first getting all kids to be able to take algebra, and then he had to figure out, like, wait a minute, I have to get them empowered to take algebra. So he started looking at how to make this interactive, and he would start with a train trip. Let's go on a train trip. We're going to learn algebra. And then they come back, and they would talk about all the math, like how it all related to math. And that's how he started. And he started this whole movement, and basically, there's lots of people now doing this algebra project around the country. And I read this book. It was very interesting about, he's looking at oppression and civil rights with black voters, and then again with getting algebra for students. And he mentioned this teacher, Constance Bland, who was a professor at Mississippi Valley State. And it turns out she was the only black woman to get a PhD in CS back in 1999. But I knew her. Well, actually, let's see. So he writes in the book about her, like she wasn't convinced at first. A lot of teachers weren't convinced about this approach that he was doing to teach kids algebra. And so he wrote that she said, I wasn't committed. I liked the idea of math based on a student's experience. And then finally, it really began to sink in how valuable this project was. And he has good stats on how it really has increased rates. But I knew this teacher because she was a co-PI on one of my grants for my NSF Alice project. She was working in Mississippi to teach kids algebra, but she never even told me about the algebra project. Like, I never knew this other history that she had. And unfortunately, both she and Bob have passed away in the last couple of years. Okay, so tip 4 is use visual and interactive tools in teaching. There's a lot of tools out there you can use. These are just a few. But the key is you need to let people see you using them, not just give them the tools to use. And they also need to see you make mistakes. So I'm going to give you a couple of examples. So Python Tutor is one of my favorite tools to use in CS1 because it visualizes what you're doing. The data structures, you can really see what's happening with them. And so there's two ways. You could actually pull up the tool and step through it there and ask questions. Or you could just copy screenshots and put them on your slides, and I'm going to do that. But you need to make sure you're pausing to ask questions. And this I borrowed from Kristen Stevens-Martinez. So this is how you concatenate two lists in Python. It's just 5 steps. Length, create, copy, copy, assign. So we're going to do those 5 steps. We have these 2 lists here, list 0 and list 1, and we want to concatenate them together into list 2. And so the first step is you want to create the length of the new list. This is the length of the new list. And Python Tutor just beautifully shows you, that inner list makes it tricky. There's that inner list in there, but you can see list 0 is just 2 things. It's the integer 1, and it's a reference to another list. And list 1 is there. So you can see the length is 3. You can see the length is 3, but you would ask them, what is the length? What do I do next? I'd be asking them. So you create that new empty list. You copy over the left list, and you can see the sharing of memory. Python Tutor is really great for that. And then you copy over the right list, and the last step is assign list 2. And again, I'd be asking them what happens next, what happens next. Here's another example from some tool I like to use when I teach automata theory called JFlap. All right. So I use it in class. Like I don't just, I would use it in class to say, okay, we're going to build a finite state machine. You have to tell me what to do. Like, okay, what do I do next? I add another state. They tell me I need to add an arc from Q0 to Q1, okay? They're telling me what to do. Add another arc here, add another state, add another arc. And then I'm going to make mistakes. Oops, I added that I wasn't supposed to. I got to go to the delete button. I got to delete it. So they're going to see me make mistakes. And then some things may not be obvious. I need to make one of my states an initial state. I have to click in a certain place, so they may not see that. But they'll tell me what to do. I need to make this state final. And then I can run it on an example string, and I can ask one of the students to tell me what input would you like. Okay, so I'm very interactive, working with them, and they tell me what to do when we run it, and we see, oh, look, this one is non-deterministic. Okay, so we can point out things that are happening with it. We keep running it, and we can see there the string was accepted. So I use this in class like all the time. I use it for stepping through proofs, and again, they're telling me what's going to happen. We can show some parsing, like takes a long time. Again, pause and ask what happens, do that all the time. They can use it for homework problems to check answers or solve problems, compare parsing methods. And what's really cool is they can use it for studying for exams. Like, can you give us more homework? Can you give us more problems to say for the exam? Like, make your own problems. You can do it in JFlat, right? And they see that. I also like to give them problems that are impossible to solve, okay? So, like, for example, I might ask them to write a context-free grammar for this problem. And this problem is not even context-free, so you can't do it. It's impossible. So I give it to them. It looks kind of like what we've been doing. And they'll spend like 5 minutes on it, and you can see they're like confused. They're trying. They're really trying. They really want to try it. And I'm like, hey, if you have it, I want to see it. Let me see it if you have it, because you can't do it. It's impossible. Okay. And eventually I'll tell them that. And so what's also kind of fun is like, let's ask ChatGPT to solve this impossible problem. So I asked ChatGPT, can you write a context-free grammar for this language? And it says, yes, I can. The students love that. Here's a grammar. It's like, okay, that's wrong. So I tell it, but this string should be in the language and your grammar doesn't generate that string. It says, okay, you're correct, my apologies. Here's the grammar you wanted. Okay, it's also wrong. So I said again, hey, but this grammar generates a string which is not in the language, okay? So then ChatGPT sat there and thought about it for a while. I was thinking maybe it's going to find somewhere on the web that tells it this is not a context-free grammar. But no, what it did is it came back with the first grammar it gave me. No, that's the one you already gave me. And it said, I hope this updated answer is helpful. Not only that, it gives me a derivation that's not even a derivation. I'm like totally confused at this point. And it's like, okay, but that's good for the students to see that ChatGPT doesn't always give you the right answers. Okay, totally busted. Okay. So if you can't find a tool, one thing you could do is try and build your own or get students to help you. Again, all my tools have been built by students and helped. So here's just a few tips on that, especially in the theoretical area because I work more in there. Like one thing we notice is like states in finite state machines, well, they have meaning associated with them. So it'd be nice if the students could write that meaning. So we added at some point annotations on states. We allowed them at first, you could just test like one string at a time, and we created a way that you could create lots of examples at the same time. We also made it so that it was very general, so it worked for lots of different definitions of finite state machines and in PDAs. And we added batch processing at some point. And again, sometimes some tools, there's a lot of things to do when you're following an algorithm, and so we have this way for them. You can try a few, and if you get it, then you can go ahead and complete it so that you don't have to do it all, or even do parts of it. So we have these things where you can do parts of it, and you can do enough to see that you've got it. Other tools, like I haven't done this in JFlat, but other tools that people have done with algorithm visualization, they've added like pause and checkpoints or pop-up questions that are asking you, do you understand what's going on? Answer this before you go on. And then very important is how you name your software tool. Okay, so, and I have students sometimes come up with names for the tools they're developing. And I had this tool called Jawa, which was about algorithm animation. But the problem is Jawa is also a Star Wars character. And if you Google, even though it's a different spelling, If you Google it, you mostly get Star Wars. So I have no idea like if anybody ever used that tool. So with JFlap, it was originally named FLAP, which was Formal Language Automata Package. I picked this nice acronym that kind of fit, but FLAP is not very good to Google either. But then in 1996, Java came around, and everybody I knew that had algorithm visualization tools were creating a Java version and just adding J to the name of their tool. And I thought, well, I don't know, that's kind of dumb, but I'll do it. So I added it to J, and I had JFlap. And it turns out that was really a good thing, because JFlap is not a word in any language. Think about that. If I Google it, I get some of my stuff, but I also get, oh, cool, somebody has created a video on it, or somebody has taken my user manual and they have it available for their students. Somebody at Rose-Hulman has, so you can see blogs about it, but every hit is almost like every hit out of 80,000 or something is my tool. That's really cool. So really think about the name if you create a tool. Make it very unique. Okay. 3 more tips. So use applications to show why they're learning stuff. In CS1, at the end of the semester, we built a recommender system, and it's a really great project because it pulls together everything we've been learning. Dictionaries, parallel lists, all kinds of things, and the students really, really like that. Automata theory is really hard. It's theory, and I get this question all the time. Why are we learning this? Okay, so you want to relate it to what they know. They've all had errors when compiling their program. Oh, you have an error on line 63, okay. So what I do when I teach automata theory is I get them to write a very small interpreter, not a full-blown compiler, just a very small interpreter for a programming language that has 6 or 7 lines of code, very small. But it's very cool because they get to see where all the things we're learning are there. We have to write a context-free grammar to define the programming language. We can see that for NPDAs model the LR parsing process. We talk about that. And when you build the LR parse table, you have to build a DFA that has meaning associated with it. And so they're pulling together everything they're learning and putting it into this programming project, which is, again, is like a 3-part programming project in addition to, we still do proofs and all that other stuff. And so I spent my pandemic summer writing about this and adding 3 chapters of parsing into someone else's book. So that's what I did for my summer 2021 pandemic summer. Okay, tip 6 is make it hands-on and fun. Okay. Now, you can use cards in a lot of different ways, but one way is to explore different kinds of sorting algorithms and getting students to come up and everybody have a card, and then they reorganize themselves in some selection sort or bubble sort or whatever. But the problem is our classes have gotten big. So you can also buy these cards online. They're 14.5 inches tall. That's 36.3 centimeters because we're in Canada. And you can see the other playing cards on the bottom there. You can see they're really tall, but you hold those up in class, and they just laugh when I pull them out of my bag. It's like, oh, we're going to do cards today, and I pull these big cards out. And I like to bake. So I also make sorting cookies. So I have these boxes of cookies. They each have a number on it. And then again, I'll get 6 people to come up, pick out a number, stand up here, and we're going to sort each day in selection sort or bubble sort or insertion sort. Okay, so lots of sorting. So when I teach automata theory, I used to do this, where I would go to class ahead of time, and I'd set up a Turing machine. This one's made out of blueberry muffins and icing. And usually it would have something wrong in it. And they would have to figure out what's wrong with it. And then they could eat it. And then I thought, why am I spending all this time here? Why I should make them do it? So this is this semester. And I came in with cookies and icing. And I gave them 2 different problems for automata theory to write a DFA. And then they had to build the DFA in groups. And you can see that classroom was auditorium style. It wasn't very good, but it had this big table in the front. So I have 3 groups on the big table and then 2 little tables. So we had to everybody come up here and we'll figure this out. But they loved it. They were so excited. And it's a great ice too. Okay, and I mean, you can also just surprise them with cookies too. So, whoops.
Today, we are going to make
Sorry. Yeah, so this was last semester. Finally, I could bring cookies in the classroom again. And so this was just made Python logo cookies at the end of class, and they had no idea. And the last slide was like, oh, by the way, somebody's set up all these cookies outside the classroom, and you could go enjoy them. And again, you could see they were very excited about it. Okay, and then in March 2020, the pandemic happened, and I was like, oh, can't make cookies this semester. So instead, I thought, well, I'll just make a video and tell them how to make their own cookies. So that's what this is.
Java cookies. Okay. We're going to start by putting in 2 sticks of butter, and you stir it a lot until it's consistency like this.
Okay.
So I have printed out the Java logo, and I'm just going to cut it
This
out.
is an abbreviated version. The video is too long to show. So this is.
The cookies are ready. Oh, they smell really good. Now we're ready to ice the cookies, and we'll just get some white icing on it. Now I'm going to add
I'm really
blue
fast.
one. So let's add the red. And we are now done with decorating the cookies. And the cookie all
Okay. So there's a longer video if you follow the link, and you can see like the ingredients and how many to put in and stuff like that. Okay, and so the last tip is just make change happen. Okay, that could be changing your lecture, borrow. I steal things from all kinds of people, but borrow your lecture, borrow ideas. Also change lives. Like I would never have gone to grad school if my math advisor hadn't, encouraged me to do that. You can mentor a junior faculty. I'm even mentoring staff because during the pandemic, we hired so many new staff. Like I'm mentoring them too. So mentor anyone you can. And you can attend mentoring workshops, even faculty. There's CRA Leadership Academy. There's all kinds of workshops, especially for grad students. Encourage them to go to workshops, mentoring workshops. And one more thing that had a big impact on me was Nikki Washington and Shawnee Daly are running this program to change the culture in computing. So I've spent so many years on trying to help women in computing, and then just realizing that, wow, blacks and Hispanics, the numbers are so much lower than women in computing. I really need to do more there. And they have this program you can go and participate, and I think you can still apply. But I strongly encourage you, that had a big impact on me, taking that program. Strongly encourage you to do that if you want to make change. So I'm going to stop here and see if you have any questions. I don't know. We have 2 minutes, it says.
Hello, is this on? Yeah. Over here.
Oh, there you are.
Yeah,
Okay, sorry.
yeah. So just firstly a personal thing. My name is Viraj Kumar. I'm from Indian Institute of Science. And I'm here and in this community now thanks to JFlap and a question that my student asked while using it. So I want to thank you and I want to thank her for my being here. My other question is, going back to your 7-step process, the Comped paper from 2019, I'm wondering if, in your experience now with tools like Copilot, ChatGPT, and so on, there's a greater emphasis and a greater incentive for students to focus on those first 3 steps and the feedback loop. In the slides, I don't think it was quite visible, the feedback loop, but that's a terribly important part of it.
Yes,
I'm wondering if, in your experience, it's easier, there's a greater incentive for students to invest on those first 3 steps in particular, because from there, going to code, if you do those first 3 steps well, these tools are better at generating code. Thank you.
Yeah, okay. I wasn't sure what your first was there a question in the first
No,
question?
the first one was just a thank you.
Okay. You said there were 2 questions. Okay. As you saw with the quote I put up also, like those first few steps are so important. And I'm not familiar with all the tools that you mentioned, but if they have ways to do that, that's great. Because even just doing it in class, it's so important to do those first few steps and them seeing you do it, like in class. Like, we're going to do this, but pencil and paper on hand, watch me do it. Or put it in the slides and slowly reveal it is another way. But yeah, it's so important to do those first few steps. I'm still actually trying to figure out the translate to code. That just seems like too much of a jump. So I'm still trying to figure out how to break that down a little bit more. And that's having a toolkit maybe to understand, like we do talk about, here's some toolkits, ways of when do you think of which one to use. So I'm working on that part a little bit more now, yeah. Thank you.
Good morning, Susan. Thank you so much. Thank you for all you've done for our community. Thank you for this inspiring talk, which I hope all those people with newcomer badges are saying, oh, wow, I could do so much in the SIGSI community. And thank you for being willing to disclose your neurodiversity. I have a potentially unfair question, but when I think about algorithm visualization, I worry about my students with vision problems or neurodiversity that makes it harder for them to understand these visual representations. How do we simultaneously support the students who really benefit from these visualizations without disadvantaging the students who can't use them or have more difficulty using them?
Okay, yeah, that's a very good question. There's one thing you can do, I guess, is not even just tools, is your PowerPoint notes, put in alt text, okay? I gave them my slides and I was like, oh wait, I gotta put in alt text and all those figures. And so I went back and did it and then gave them my slides back. And the visualization tools, I haven't done it myself, but other people have taken JFlap and put in some of that. Yeah, so it is something you wanna think about when you build a tool, yeah. So
thank you so much.
All right, thank you. Okay, hey Jeff Forbes.
Hey Susan. So first, I wanted to thank you for sharing. You know, I had an office next to you for 20 years, and I learned a whole lot today.
I'm really good at masking.
Yes, you're incredibly good at masking. But I think that's really great for everyone to hear, and you know, all that you've achieved. I think anyway, it's even more admirable. But I had one question about, you know, one of the things you talked about was borrowing, and I think that's really actually a very important thing in teaching is, you know, borrowing from other people and figuring out how to make your course better. How do we do that effectively for everybody? Like, do you have an idea of like, you know, what makes it so you decide to borrow from someone and, you know, you've been doing a lot over the years and like a lot of people have borrowed from you. Do you figure out why they borrow from you? That's a hard question, but.
Okay, well, one thing is I put a lot of my materials out there so you can borrow them. All my class notes are up there. You can borrow anything you want. I think you need to, well, yeah, so first of all, coming to SIGSI is a big thing. And you can't, let's see, so like if I'm going to teach a new class, like I just starting from scratch is really hard, unless it's like completely new, no one's ever taught it before. But talk to other people. Like someone may have notes, check other people's and pick and borrow them. Even like writing grants, it turns out a lot of people don't know. Anybody that has a grant, you can get their write-up for their grant. They're supposed to give it to you for free. Like I did that when I was first writing my grant. I borrowed like 3 other people's that were similar grants, and a lot of people don't know you can get that. So just talk to people. I think one thing about the SIGSI community is everyone is so friendly. Like I was going to theory conferences and it felt so competitive. Then I came to SIGSI, it was like, oh my gosh, everyone's so friendly. People we're happy to let you borrow things. Just talk to people, they're fine. Yeah, they'll let you, sure.
So I know you said there was only one more question, but this is not a question. I just
Kristen
wanted to let you know.
Stevens-Martinez is speaking.
Oh, I'm sorry. I should know better as the hybrid experience chair. Kristen Stevens-Martinez from Duke University. I just wanted to let you know, Susan, that people online are also saying thank you.
Okay.
And Vida Movahedi especially wanted me to come up and say thank you for everything.
Okay, thank you.
Thank you so much.
All right.
Congratulations.
Oh, okay, thank you. Okay, let me get one water bottle.
So Susan, thank you so much for your presentation. It was fantastic. This brings this morning's plenary to a close. There are snacks and hot drinks next door in the exhibit hall, and please do take a moment to visit our exhibitors and support them. They do make a huge contribution to the conference. Thanks very much.